a lot of snake oil, and increasingly regulations affecting what building owners have to do related to energy efficiency in their buildings. Today, we want to talk about results. We want to talk about what we found actually helps improve efficiency, what's feasible, and not so much about what doesn't make the cut. Vista is an energy efficiency firm based in Silver Spring, Maryland, just across the district border here in the Washington, D.C. area. We focus on high energy intensive buildings and buildings that are 24/7 occupied, which tends to make projects, deep energy retrofit projects, much more difficult. But it also gives us a very good idea of how to actually achieve the types of results that people do a lot of talking about these days. Our approach starts with a whole portfolio. We look at all the buildings in a portfolio and identify those that could benefit most from energy efficiency upgrades. We do thorough assessments in those buildings, identify specific projects that will achieve the results we're looking for. We almost always do retrocommissionings in buildings to fine-tune and tune up the equipment that's there. And then we go into a measuring and verification process to ensure that the efficiency gains that we estimated are actually achieved. This presentation will go through that process much more slowly, and that said, there is a lot to cover. We'll be talking fairly quickly and skipping over some things that you might find useful, so feel free to ask questions, and we hope to get to everything in the end. With that, I will hand this over to Zack Moore, co-founder and principal here at Vista. He and I will be tag teaming throughout the rest of the presentation.
Great, thanks Mark. This is Zack. Hope everyone's having a good afternoon, evening, day, depending on where you are in the world. So skipping back to the beginning of what Mark mentioned, a lot of folks with portfolios will take the shotgun approach of send assessment teams to every building, try to identify efficiency measures, and then go through the implementation and measurement and verification process. We try to come out of the gates to be a little more time and cost efficient than that. Really, the first step for us is what we call portfolio triage. We want to pull together all the data that we have in the portfolio to be able to identify the largest spending buildings and therefore the largest opportunity for efficiency gains. So there's many different methods to this, but fundamentally you have to pull together all of your utility bill data, benchmarking data, identify any big anomalies in the portfolio, and also site-specific operations and equipment. So with that, once we identify hotspots in the portfolio, we then jump into assessments. And assessments at each building really should be tailored to what we see on site. This really can be broken up into three major categories: demand side concerns, supply side concerns, and financial goals for the owner. So for us, whenever we look at demand side goals, we're really looking at what is the building, what is its equipment, what are its operations on site, what are upcoming planned projects, what existing issues does the building already have, and then moving into supply side, it's about what is the cost of electricity coming into the building, what is the cost of gas, do we have the opportunity to go out and procure cheaper electricity and gas. That also means on-site generation through renewable energy. And all of that has to come together into, obviously, the financial goals for the owner. So talking more specifically on focusing the assessments, the three major categories of assessments are ASHRAE level 1, 2, and 3. We typically draw the line to go ASHRAE 2 and above if the facility has a central plant. We feel like there's much more opportunity to dig into major pieces of equipment, controls, and its effects on operations and utility spend if it has a central plant. If not, we feel like ASHRAE level 1 is detailed enough. Moving into the financial considerations, the way that we break down our analysis is we always first want to make sure that the assessment itself is looked at as a return on investment. We don't want to just produce reports for no good reason. So stepping into the assessment, we need to make sure that we have an operations and maintenance focus to identify measures on site that are quick fixes and have immediate payback. To that end, we break up our energy conservation measures into no low-cost fixes and capital-intensive opportunities. And hitting back on additional focus, again, this is site-specific. It really depends on known issues and projects that are upcoming at the site, any potential energy procurement, and potential for renewable energy at the site as well. So with that, I'm going to hand it back over to Mark real quick to talk about diving deep into energy conservation measures.
Thank you. Well, once these measures have been identified as potential during an assessment, it's our job also to make sure that the projects are viable. The owner doesn't want to hear a lot of pie-in-the-sky ideas. They want to know what they can actually do and how soon they can do it. So viability means a lot of things, and for this presentation we're talking about financial viability, the effectiveness of the measure itself, and physical viability and feasibility. We tend to see a lot of positive ROI for the projects that we propose, and we therefore present the green side of green to the owners. This is the dollars and cents, and not so much the ability to feel good about the building or to advertise your low carbon footprint, etc. These are pure investments for a lot of owners. Being in the commercial space, they tend to have a payback threshold of 3 to 5 years, which can be quite aggressive compared to some more institutional type buildings. And we also need to ensure that the projects themselves are each self-justified, meaning you don't look at 10 projects that have some better and some worse paybacks. Each individual project needs to be self-justified. So here's a little table on the side of the slide that shows a simple payback for a number of different projects that may have been proposed in an assessment, and each one has an individual payback there. You can see one there, the guest room thermostats above, a 5-year payback. This particular client did have a 5-year payback threshold. So that one either wouldn't make it or needs to be justified for some other purpose. In this case, the automation that you get from network-controlled thermostats and a little bit of modernization in a hotel is what made that owner decide that they wanted to move forward with that project. But in that case, it was self-justified. Effectiveness, basically we just look at a very conservative estimate of energy savings for this given space, making sure that the measure is tailored to the space in question. And then physical feasibility, can you get the equipment in there? Can you do it at a time that suits the operations of the facility itself? So I'll dig into these in the following slides. First, on the financial side, we need to make sure that we have very realistic project cost estimates. There are RS means and many other types of estimating project costs, but they're all still just estimates. We try to take a multifaceted approach and fine-tune that estimate as soon as we can in the process, so we don't go too far down the road and find out later in the game that the project isn't going to happen. So getting contractor input can be very valuable. Talk to the people who are actually going to do it, see what they think it's going to take. Draw from past experience. If you have an idea of something that you want to do, but it's a new place, you can start with an estimate of where you were on the last project, and then factor in certain variables for the new facility. Is it union labor in that town? Are there going to be third-party fees like integration with an existing control system, and there's an incumbent controls contractor that needs to be part of the project? Will there be permitting requirements and fees associated with that? Historic review, for instance. And is it a 24/7 operation, meaning that you need to use overtime hours to actually get the work done, for instance, in a central plant utility switchover? And of course, add a contingency. You don't want the project to die at the last minute because you forgot that there might be asbestos on site or something of that nature. The flip side of the payback equation is the estimate. The utility savings estimate. Again, you can get the contractor input here. This is valuable when you're dealing with specific equipment that a contractor or a vendor might know very well, and they have very fine-tuned cost estimate calculators. However, contractors tend to be quite optimistic in the savings that their equipment will bring to the owner, and we found that that can be overstated by 10% or as much as 50%, depending on the contractor we're working with. So keep that in mind, and also it's imperative to come at the equation with your own estimates and to make them as conservative and realistic as possible. When we talk estimates, we tend to work with straight, fairly simple calculations. I say simple relative to complex energy modeling. A lot of people think of energy estimates as coming from the sort of BIM models and thermodynamic modeling that you might see for a projected building. But we found that calculations, pen and paper, tend to be just about as accurate and much more cost effective and faster in getting you to the answer. That said, we do work with very good engineers, and we are engineers ourselves. We tend to look at engineers and work with engineers who have experience with the energy modeling. You can't really just take any mechanical engineer and say, what are your estimates? Because they might not be quite as in tune with the modern energy efficiency approaches and controls strategies that might be out there. A lot of their experience might be with projects that have already been value engineered, so the equipment that they're used to installing is basically the cheapest you can put in a building, and those aren't the engineers that are going to get you the best estimates if you're trying to replace a more complex model with simpler equations. And I encourage everybody on the team to brush up on their own physics. Take a step back and look at a space and think, how is air going to flow through this? Or if we have BTUs coming in the gas line, how are those BTUs exiting? Where are they getting used? Where are they being absorbed? Where are they being rejected? So don't be afraid to ask questions, even if you're not an engineer. Just sort of think rationally about a project in the space and question, is this going to provide savings? Does it make sense for this building? And then let the engineers answer the question for you and possibly steer them in a better direction than they were going without your question. And of course, to stay conservative, we always err on the conservative side of every assumption. Surely you need to make assumptions throughout the process. If you always err on the conservative side, you will always trust your estimates, and you won't have to sort of sweat and think in the back of your mind if maybe this project isn't going to work out because you were a little too aggressive when proposing it to the owner. That's not a good feeling to have on implementation day, or when the owner starts to question whether or not the savings are going to be there. You want to say for sure you know that they will. Now, if you have done the payback calculation and you're close to the threshold, or even if you're within it and want to go for some extra dollars, there are a lot of people out there that want to pay you to improve the efficiency of your building. We've listed just a handful that we've worked with over here on the side, but they consist of utility companies, local jurisdictions. There are a lot of regional programs. Cities and counties will offer their own incentives. There are combinations of utilities and governments that work together, such as DCSEU, which is here in DC. And then there are tax incentives, federal credits, and rebates available. And with all of these incentives, there often are prescriptive measures. Maybe they'll give you $7 for every LED lamp you install. And there are custom measures and incentives that they'll provide. So get creative. Look at the paperwork and see where you might be able to get additional dollars from an incentive authority who's willing to pay it. One example here in DC, we had a prescriptive measure for a chiller that was offering $7,500. We dug into the math, we dug into the paperwork, got together with the utilities engineers, and we turned that into an $88,000 incentive available for that same project. If you are the party that is looking for the incentives, you may find yourself in the position of overseeing the incentive process and ensuring that the incentive requirements are met. Often this means careful project sequencing. Can't tell you how many times a contractor has wanted to start demo or sign contracts prior to the incentive being approved by the utility and the funds being set aside for the project. If that demo starts and a pre-project site inspection was required, there goes your incentive. You've invalidated the whole process and the money doesn't come through. Also, there may be a baseline measuring period required, so the owner may need to know that they can't start their project for a few weeks, and there may be a post-implementation measurement and verification requirement, meaning that the owner might not get paid for 2 weeks or a year after the project is implemented. Keep a close eye on those. Now, when we talk budget, is a project financially viable? Sometimes we need to re-educate an owner on how to think about a project. They are used to thinking of capital improvements as something that improves the asset of the value, or the value of the asset, but that's not all these energy projects provide. Compared to, say, improving the signage or upgrading the carpet in a building, which does add value, these are investments. These projects provide a return on investment. They provide a financial reason to move forward. So if you, say, have a budget where you have a line item for carpets this year and a line item for chillers next year, encourage the owner to swap those. Get the chillers going this year, start that payback clock so you're 1 year closer to meeting that payback deadline, and get paid for the improvement. Use that extra money that you might save to upgrade your carpets next year. If there's already capital budgeted for, let's say, generic kitchen equipment upgrades, look at that line item and see what can you do on the energy side using the existing dollars that have already been budgeted. Maybe you can put in hood controls that respond to the demand in the cooking environment and control the fan speed accordingly. Or upgrade the compressors for your walk-in refrigerators. So there are a lot of items that might be budgeted already that can be turned into energy projects if you just think a little bit creatively about the owner's capital. Physical feasibility could shoot your project in the foot. First of all, make sure that the project is realistic. Once you get some competitive bids in, those contractors might have found some of the drawbacks and the complications that a particular building might present. They will factor that into their price, but more importantly, they'll identify those for you so you can see if the equipment will even be feasible. Will it fit? Can you get the chiller into the space? Can you run the boiler's flue up through 17 floors and out to a part of the building that isn't going to interfere with an adjacent building? Is the whole proposal code compliant? Does it meet new codes? Is the existing equipment grandfathered and new equipment would not be code compliant? All of that needs to be considered before the project moves forward. And as well, it's important to consider the operations of the facility itself. There may be existing controls with which you need to integrate, but there are always existing occupants with whom you need to coordinate. And in every project, just standard project management, communicate, communicate, communicate. You don't want a last-minute problem or a miscommunication with the occupants to add cost to the project, sabotage the payback, and then make it look like the measure was a bad one, when in fact it was just project management that killed the energy project. So the next few slides are some actual projects that we found to be successful. This is some of the real-world implementations that we've gone through and we want to share with you. I'm not going to go into each project in detail. This is more of a reference. Feel free to ask questions at the end. But these are the projects that we can say in many cases will provide considerable savings for owners. Starting in the central plant, high efficiency boilers. Get rid of those old 1950s steam boilers. Put in maybe a series of smaller condensing boilers that can be sized to adapt to variable load, and throw most of their BTUs into the hot water itself and not up the flue. Same thing with your chillers. A lot of modern equipment has hit the market lately. We have magnetic levitation out there, which sounds like something from Back to the Future, but is being used today to cool buildings all over the world. And as well, thinking about the sizing of the chillers so that you can hit your baseline load as efficiently as possible and your variable load as efficiently as possible, and use lead lag sequencing to make that make sense. Combined heat and power, why not generate some power and create some hot water at the same time? Free cooling heat exchanging always makes sense. If it's lower than 55 degrees outside, no reason to run your chiller, just eject your heat straight outside. Similarly, throw a heat exchanger on the front of your chiller, preheat your water coming into the boiler so it doesn't have to heat it as much because you were already making heat with your chiller. And if you're tired of watching water go down the drain while it's steaming from your steam system, throw a heat exchanger on there to capture some of that heat before it literally goes down the drain. Controls, retrocommissioning makes sense almost all the time. Zach's going to talk about that a little bit later. Building automation saves both energy and operational expense because your engineer might have to walk across a compound to turn a thermostat up or down 4 times a day. Variable speed drives so that a pump only runs at the capacity that's required to get the job done. Carbon monoxide sensors in garages and carbon dioxide sensors in conference rooms, so that you only change as much air as you need to based on the use of the space. Occupancy sensors on thermostats, networked thermostats that allow an engineer to control the whole facility from his desktop. And as I mentioned earlier, hood controls that respond to cooking activity to run the fan only as much as necessary. Lighting, many engineers and building owners out there are upgrading their lighting, and we highly recommend it. We have owners that will use only LED technology and won't even consider CFLs or fluorescents, but we do a lot of LED replacements for all types of buildings, and typically that's just screwing a new lamp into an existing fixture. However, parking garages with their light intensity requirements often do need new fixtures, but we find great ROI on those. T12 to T8 replacements are a popular one. Occupancy sensors only light up a room if somebody's in there. And again, with all the projects, we want to make sure that each project is self-justified. Same is true of lighting. Don't just throw in a 10-year lamp, 10-year payback lamp with a 3-year payback lamp. Make sure that each lamp that you're proposing or each fixture you're proposing is self-justified. Water fixtures, low-flow faucets, not the little spray things that you see at the airport, but there's some great aerators out there that provide excellent water feel, if you will, make it feel like it's a normal faucet. Shower heads in hotels and barracks and buildings of that nature. A lot of water wasted in kitchens, pre-rinse sprayers. Throw some foot pedals on there so the cooks don't leave the sinks running all the time. Recycle your water from your laundry and heat. And submeters. Submeters save cost, not so much save water, but since sewer rates tend to be higher than supply rates, there's no reason to pay for water that's not going down a drain, such as in your cooling towers or your irrigation. And if you have to irrigate, the submeter makes sense, but it's best to talk the owner out of irrigation altogether. Each of these projects does have an interaction with other projects being proposed. I describe them as synergies and also drawbacks and counteractive measures. So the synergies are that if you want to do a retrocommissioning, it's a great time to install a building automation system. And those two projects build on each other, improve the efficiencies of each other, and improve the payback of doing both projects. Also, equipment downsizing can be synergetic. If you are installing thermostats that reduce the overall building load, you might be able to reduce the sizing of the new chillers you're proposing in a chiller retrofit. That reduces the chiller cost and maybe improves the payback of that project enough to make it get through the ownership threshold. Same thing with water heating, preheating. You may be able to lower the sizing of your boilers and get that project approved. And lighting, if you're using more efficient lighting, you're reducing the amount of heat that's being produced, so you can downsize the boilers perhaps and make that project viable. Similarly, there's counteraction here in that reducing load reduces the potential savings of another projected project. So if you're reducing the heat output of the lighting, the chiller, which you knew had an annual use of a certain amount before the project, is going to have its load reduced, which means making that chiller more efficient isn't going to be quite as useful as if you hadn't done the lighting project or if you hadn't put in centrally networked thermostats. So you do have to make sure that you calculate your savings with other projects in mind so that you don't overestimate the savings of a project based on base load prior to other measures you've implemented. Also, keep in mind that there are often no incentives available for fuel switches. So if you're talking about taking a building off of district steam and running it on gas boilers, you may be losing the opportunity for an incentive there. Lastly, we do look at renewable energy options, but I make this last because it's always important to reduce your use first before looking at the viability of renewable energy. Often there's not enough roof space or there's not enough loop space for geothermal or photovoltaic, so you have to reduce your use as much as possible first if it's going to be even close to being viable. We do look at solar voltaic, wind, and geothermal, although sometimes they're still not viable even under the best of conditions, including a hotel we worked in once that had not only a hot spring but also a landfill that was off-gassing methane. And with those, they were not able to make geothermal work, and they were not able to make gas recovery work due to the extremely low energy rates. So all of these provide a bit of a moving target, but sometimes you can combine them into a great project that gets renewable and energy efficiency and dollar savings all under the same cover. Back to Zack for the Retrocommissioning.
Thanks, Mark. One recommendation that we always have that comes out of our assessments is what we call a site-specific retrocommissioning. There is always opportunity on site to make what you have work better, whether that means changing operations and runtime or optimizing control sequencing or just turning equipment off that isn't necessary. All of those recommendations are obviously low cost and have quick payback. So real fast, what we mean by retrocommissioning is essentially a building-wide tune-up of equipment and controls. The reasons why we always find this to be a recommendation is, many new buildings are not properly commissioned. If you have new equipment that's there to replace old equipment, a lot of times the contractors don't balance that new equipment with the current facility and other equipment that's on site. You always have meters and sensors that fail over time and fall out of calibration. And there's always new great controls technologies that are available and should be looked at continuously. And lastly, of course, the big one is occupant discomfort. If you're getting a lot of hot and cold calls, that's something that can often be resolved in a good retrocommissioning. So the approach here, as I mentioned, has to be site-specific. And you first have to make sure you have the right team. There's a lot of controls companies that are out there that will come under the guise of doing a retrocommissioning, but they really are only one piece of the puzzle. You have to have the energy engineers, the controls experts, obviously on-site facility engineering, a good test and balance firm on both air and water, And a lot of times utility companies need to involve those guys, not just for incentives, but they often have programs that will lend engineering assistance. So also in the approach, each building has different equipment and operations. So you really have to tailor the scope of the retrocommissioning to the types of air handling equipment, heating equipment, cooling equipment, and controls that happen to be on site at that point in time for that building. The focus, as I just mentioned, is typically on the BAS controls, a lot of meter and sensor calibration, just making sure that the thermostat readings that you're getting are correct and that you're not running equipment unnecessarily. And also, you want to do a retrocommissioning to be able to identify new potential energy conservation measures. When you take such a deep dive into the building, inevitably you will find more quote-unquote custom projects that will be recommended beyond just the typical plug-and-play projects that we've mentioned already. So the result of a good retrocommissioning is that you're not only getting a detailed list of the issues that you've come across in this equipment and controls, but you're also providing the list of issues that were corrected during the retrocommissioning. And along with those list of corrected issues, what are the estimated savings so that you can justify the retrocommissioning activity. Improved occupant comfort. So this is an item that often fights the item that I just mentioned about listing estimated savings. If you're not providing enough air to a certain space, obviously introducing more air is going to increase your heating and cooling costs. With that, there's many different ways to optimize how you bring that air in and out of the building and making sure that you have the right controls in place to do it the most efficient way possible. The list of additional ECMs that you came across so that you can put those in the CapEx budget or the next time you're going to do a BAS upgrade. And ultimately, you get a good retrocommissioning when it's a low capital cost and you get significant savings. Again, the controls contractors a lot of times will want to come in and overhaul the BAS. It's not often necessary unless the BAS is 10, 15, 20 years old. You really have to hone these folks that you're working with into, hey, let's make this a quick payback project. Let's make what we have run as efficiently as possible. So beyond retrocommissioning and assessments and implementation, how do you verify that the efforts you've put in on site are actually having impact? So you have to first be set up in a common platform with your utility data to be able to pull this data in and analyze it ongoing. And the top reasons for the ongoing monitoring here is project impact verification, ongoing issue identification, performance reporting to the higher-ups, and a lot of municipalities now are requiring Energy Star benchmarking and other regulatory compliance. So let's first talk about data. Where do we get data? Again, utility bills. If you have any sub-metering on site, that's good to fill in the gaps between the utility bills. BAS and equipment logs, that's another place to get even more granular with your data. Variables that make it difficult to extract what the data is telling you is changes in occupancy, changes in weather, operational impacts on site, and how does that affect anticipated project savings. And then fluctuating utility rates. Regulated utilities, their rates fluctuate, or if you're in a deregulated utility territory and you're purchasing cheaper electricity or gas, you got to make sure that your energy conservation measure is living up to its payback goals, even with those reduced rates. So the way that we do that here at Vista is we have what we call our Building Performance Management Program, and this slide just essentially summarizes everything that I've said. You first have to pull everything into a common data platform. That in itself is very challenging. Once you have that data in the same platform, you need to kick out monthly performance reports so that you can see that your efforts are on track or off track before it becomes too late. From there, you should be able to project annual utility cost guidance. So if we implement certain measures this year, what do we expect to spend on energy next year? And then you have to be able to raise this back up to the portfolio level. So we started talking about portfolio triage and identifying the hotspots across the portfolio and having a targeted approach to on-site assessments and implementation. Once you've had that and you step through site-specific measurement and verification of that implementation, how do you raise that information back out to the portfolio level to show real impact? So again, to summarize, you have to assess thoroughly, always think dollars and cents and return on investment. In your estimates, be conservative. Try to use proven technologies. There's a lot of snake oil out there. Talk to the folks that you know in industry. Don't take our word for it on what works, and ultimately it's different for each building and operations at each building. Try to focus on retrocommissioning and tuning up existing equipment. If you don't need, if you have some years left on those boilers or chillers, just make them run as efficiently as possible. That's quick payback. And then lastly, ongoing monitoring of your energy use. Not only for anomaly detection, but to prove the dollars and cents and payback on your ECMs. With that, that's the gist of our presentation, and thought we would open up to Q&A.
Thank you, Mark, and thank you, Zach, for that presentation. We'll move into our question and answer period. I did get one question from Ralph. Do you look at the building envelope as part of your assessment?
Zach, it really depends on the time horizon you have in place. We typically do not see any changes to building envelope having less than a 10-year payback. It's very expensive to replace windows. It's very expensive to add insulation to buildings. It's easier to do that for roof tops if you're doing a rooftop replacement. But generally, unless you're doing a deep retrofit and your time horizon is beyond 5 years, we often do not look at building envelope other than weatherization, leaks, and the typicals when it comes to building envelope.
Okay, we had another question regarding slide 18. What technology was shown in that picture?
Let's switch back here to slide 18. I'll let Mark pick this one up.
This is a wind turbine mounted on the side of a building. Not your typical hilltop turbine, but compact urban use for that specific facility.
Okay, do we have any other questions from the group? You can put them in the Q&A box down in the bottom portion of the screen, or you can click the raise hand icon across the top. Okay, I don't see any other questions. Mark and Zach, we certainly appreciate your presentation, and just a reminder to everyone here that this webinar was recorded and you'll be able to view it in its entirety at the Sustainability and Energy website. And that link is again down in the notes box in the bottom left-hand corner of the screen. All right, thank you again, and this is the Sustainability and Energy webinar. Join us again next week, and we'll send out the reminder for that meeting later on this week. Thank you all for joining us. Okay, I'm sorry, we did just get one last question. If you're still online, it's do you see LED opportunities which are quicker payback than T5 T8.
We do see a number of opportunities with fluorescent replacements that do have excellent payback. They can be T5 from T12 or from T8 if that produces enough lumens. But we also will look at reflector kit retrofits. So maybe you can do in a single light fixture with 2 lamps what you were doing with 3 or 4, just by more efficiently reflecting the light back down. And also, those projects often come with ballast replacements to upgrade the technology and the efficiency of the lamp ballast itself. But each project is specific to the type of equipment you have there, and obviously the amount of light that you need to get out of it, and that will affect the payback for that particular measure.
Okay, thank you. Are there any other questions before we close out? All right, seeing none, we'll go ahead and close out this meeting. Thank you again,